Alright, kind of a part 2 video for the last video. Unfortunately, a half an hour of the video was lost. Probably my fault for not cleaning out freeing up some disk space. So it's still a Linux thing I gotta get used to. They don't have like a My Computer thing where you can just easily see how much disk space you have. You know, they have this stupid Gparted thing where it takes forever to load, and it's not a very good tool for just knowing how much free space there are in your disks and such. So I have to find a tool that's more My Computerish. Anyway, so my fault probably. And lost the video at the key moment when I'm playing this video that's supposed to be a critique of some more my egregious behavior when it comes to playing videos and responding to comments even. So this was what I've deleted the comments already, so it's can't go back and read the exact comment. But anyway, this is a portion where I'm supposedly violated some rule of decency by manipulating what the other person typed and responding somehow totally inappropriately. Yeah, I don't think we're going to get that.
Without any Einstein equation, and the only flaw in it is this problem of acceleration and velocity in free space.
So the context is we're talking about Mach gravity and how well it duplicates all of the circumstances of gravity, and it has this one flaw where it doesn't account for velocity in free space, in the sense that if there was a force that could create gravity, then that force would create a friction or impediment to movement in free space. Free space would kill your velocity. And I've already explained how that's fixable.
But without that problem, it's perfect. And they keep pretending it doesn't work.
So, and especially this cowboy character, he apparently doesn't really understand the idea of an even pressure and how it would, just by the laws of probability, force two objects together. Even though Hothloday conceded this point, that if you could create a bunch of little tiny ball bearings bouncing randomly, gave them a high energy, and you put two big things in the field of those little ball bearings, the two big things would be pushed together.
Amazing.
And by the same rules as the inverse square law. They would be pushed stronger the closer they were to each other, the faster they would move towards each other.
The response is about 9-degree collisions and 180-degree collisions, as if that's something people can't understand.
All right, so he says 90-degree and 180-degree, which is never the rhetoric I use. So first you have to think, well, what is he talking about? 180 degrees, that's a reflection. And obviously, as I pointed out, there's only like 4 rules. If two similar things hit each other, just pretend these are both black, and they collide into each other, no matter how you think about it, them going through each other, them reflecting off of each other, no matter what you do, the universe is exactly the same if they're both black. But if they're two different colors, then you can understand if there's a big difference between going through each other, then black one's going this way and silver's going this way, and reflecting, and silver's going this way and black's going this way. There's very different universes. And so that's all I've tried to illustrate, is there's like 4 rules about these interactions. And so head-on collisions are irrelevant between things that have the same color. And as long as we understand that the collisions don't use up any time. And then when two things come into each other perpendicularly, they're both moving this way, the idea is that this silver one takes the black one's momentum, and the black one takes the silver one's momentum. Now, that's not too complicated. Alright, so anyway, so you can see on my face right there, I'm trying to understand what the comment is saying, right? My brow is going, eh. So I'm like, what the hell is he talking about?
And
I say, I don't know. I'm clearly explaining how I don't know what he's asking.
that response has nothing to do with the argument put forth.
That response has nothing to do with the argument put forth. I'm sitting here saying, I don't know, what does that even mean? I don't know what you're saying. I'm clearly saying that. So this is me manipulating something, showing complete confusion and complete uncertainty under what the fuck you're talking about. And he's using this as an example of me being manipulative. I mean, can you get more insane? I mean, I just don't understand. How could this possibly be interpreted as manipulation? I'm quite honestly uncertain about what the fuck the question is asking me.
I can't.
I'm ready to say I don't. I'm saying I don't know what you're talking about. I'm ready to say the same words again. I don't know what you're talking about. This is me manipulating, saying I don't know what the fuck that means.
Help you. I have images on.
Yeah, I say I can't help you. That's being manipulative. I don't know what the hell you're talking about. I don't know what you want me to say. What do you want me to? What are you doing? I can't help you. This is me being manipulative.
On the website, the collisions, not all the black things go 180 degrees, not all the red things go 90 degrees.
So see, because you say something happens, there's perpendicular interactions and there's reflections. Because you say there's different reactions, they say, well, you mean it happens every single time? No, under each circumstance, it's a little bit different. There's like 4 varieties of interaction. And somehow, you know, these assholes want to keep turning what you're saying. They want to keep perverting what you're saying. They don't want to honestly argue what you're actually saying. They want to argue some perverse Frankenstein monster of it, some perversion of it.
There's rules. The 2 different colors have 2 different opposite reactions. So there's 4 little simple rules, asshole. It's just no point. Then
okay, so again, I just don't understand. So he forces me to go watch this because this is evidence of me being a cheater and a manipulator. And where's the evidence of me doing anything but honestly saying I don't know what the fuck you're talking about? What is it you want me to answer? What's the question? I don't get it. I don't understand your problem. Amazing. Just fucking amazing. All right. So the other question, it's still here. Some guy asked, Gary, Expose UK. Gary, rather confused. I thought GPS satellites proved Einstein right. All right, so this is, it gets complicated because look, there were stories written long before Einstein. The Time Machine, for example, a famous movie. Lots of conversation before Einstein about the connection between speed, that is going faster than time, and time travel, which is a lot like the same subject. So, you know, this idea that Einstein invented the idea of it, and then somehow it was demonstrated in the future that, oh yes, Einstein was completely correct, there's a relationship between velocity and time dilation, that is, clocks moving slower. Not necessarily any real time dilation, just the fact that clocks don't tell time very well, especially atomic clock. Clocks dependent on a chemical process. Chemical processes, nuclear processes, are retarded by motion. That's the argument. So that's what's been proven, that there's a connection between velocity and retardation of chemical process. And I would analogize that by saying, like, if I asked you to dance as fast as you can, and then I asked you to move left while you were dancing as fast as you can. The fact is you wouldn't be able to dance as fast because you have to take some time not to dance to move left. So there's no, so there's clearly a relationship between the fact that velocity is a distraction. It causes an internal change, and that change means the thing can't be doing what it would do if that change didn't happen. If velocity didn't happen to something, it would be able to behave differently than if velocity happens to it. It's a simple argument. So velocity steals time from process and therefore gives the appearance that time has changed somehow, when no, just the metabolism has changed. It's taken longer. I have you swallow a big giant, I don't know, whole grapefruit or something. it could slow down the process of your guts. You know, I mean, it's not a great example, but it's just the idea that you've changed the circumstance. So all that was proven, all that's been proven by evidence, is the relationship between velocity and a retardation of certain atomic processes. That's been proven. The idea that space is bent and that time is a dimension has not been proven. Einstein hasn't been proven right on that. You have to understand that this theories of Einstein collected ideas that were around, Maxwell's equations, different kinds of things, and just cobbled them together into a theory. But they can still be understood as separate ideas that he tried to smash, that he tried to unify. And they don't need to be unified, and the evidence doesn't prove they've been unified. Alright, and that gravity dilates time, which is why they have to adjust clocks to compensate. So again, gravity doesn't dilate time. The velocity gravity causes dilates time. So, you know, you got to be able to understand the separation. There's nothing intrinsic about gravity that dilates time. It's just the velocity it causes. Gravity tends to cause velocity. Otherwise, GPS wouldn't work. Well, again, it doesn't exactly work, so that's another trick here, is it's mathematically a little bit off. Is that not true? Yes, it's not true to assume that because Einstein, part of general relativity, addressed the issue of time dilation, that the connections it made between velocity and time dilation are necessarily what it predicted. It predicted something much more complicated, and that hasn't been proven. There's no proof that that space is bent or that time is bent, and that's why there's time dilation. There's only evidence of a relationship between velocity and the degrade of the metabolism of atomic structure. That's all, the only thing that's been proven. So you just have to understand the proof is not for the general theory of relativity. The proof is for one tiny element that could be assumed to be part of the theory, but not entirely, which is the relationship between velocity and time dilation, not a relationship explicitly between gravity and time dilation. You don't need gravity to time dilate. You can do it with any velocity. Okay, so anyway, so in Superior Mind, I read some of this before, I don't know if I'll bother. It's basically about the tension argument and why orbits of electrons around protons, and why the electrons don't crash into the proton. And so I've sort of vaguely went over this before, so I drew a little picture. It's close enough to good enough, and so we'll just go back to that because that was the last thing I did in the video. And the point, I made these as electrons, little blue things, and this is the proton. And this is a point I've made before, but I don't think these things are orbiting around and doing all this crap. So when you have a shell that has like 8 electrons in it, the 8 electrons are evenly spaced in the shell, and they might be rotating. I'm not saying that's not happening, but speed isn't what's keeping them from crashing into the proton. What keeps these electrons from falling into the proton is the distance between the electrons, their repulsive force. So you can see that for each electron, you could basically draw a line between for 3 electrons. You could basically understand there's a line where you cross, and before you get to that line, everything towards that line, you're actually creating more pressure between these repulsive electrons. So if I bring this electron closer to try to get to this proton, the truth is I'm going to create more pressure on these other electrons. I'm going to get closer to them, and to do that creates more pressure. And so the point is these electrons are going to resist this electron trying to move closer to the proton. And the same is going to be true for every single one of the electrons. There's going to be these two, Mo and Larry, are going to keep Curly from getting closer. So that's why once the electrons are in a pattern, they tend to stay in it, because nothing can occur into So if there was another ring inside of this, clearly if some electron breaks this line, crosses it, gets hit hard enough and it crosses this line, it would bounce into the next geometry, and that geometry would gain another electron, and so the tension between all of those electrons would increase, which means that that orbital will actually get a little bigger. So that's sort of the irony of it, is when you move an electron from an outer ring into an inner ring, it's going to expand that inner ring a little, which is also interesting. But anyway, so as I pointed out, there's a ton of this chemistry stuff which gets into the whole geometry, and it's all the geometry of magnets and tension, and it's really interesting, and I really want to do that someday, but I really can't. I mean, first I gotta get the basic theory accepted, and then I can do some of this other stuff. But I mean, clearly there's a ton of geometric arrangements that you could understand that would create different kinds of tension that would allow electrons to more easily violate this line, or more difficult for them to violate this line. So just this line is the key line, because to move this closer, this pressure gets greater. And so anyway, but I think this has everything to do with how electrons move or migrate, and why it's all or nothing. Why they go from this orbital shell to a wider orbital shell or an inner shell is clearly because once they either have to be pushed out or they have to go in. They can't be in between. So there's no point in between where they're comfortable. They're only going to be comfortable far enough away from these two electrons, and far enough away means they're either here or they're substantially in here, but they can't be in the middle. So the transition will always be a quick transition. So anyway, but it's a really interesting subject, but I just don't know how much time I want to devote to talking about the geometry. But like I said, you can just imagine how this kind of geometry would change all kinds of. This distance would change for each, polygons, hexagons. They'd all have different kinds of geometry, and we also have to remember this is all three-dimensional. So this geometry is going to be in 3 dimensions, and lots of interesting arguments could be made about the different pressure and which way an electron is going to tend to want to move because of that tension that it's caught in. And so the closer that is to this line, the more likely it is you're going to be able to cross the line. The further away from the line, the less likely it is to cross the line. So they have all kinds of stuff to do with stability of atoms and all that kind of crap. And whether they're an acid or a base, and lots of interesting stuff. So anyway, so sorry for the lost responses to the lost comments, but shit happens and such. They were all just comments by the cowboy, and they were all just asshole comments. Something about the 2-slit, like he made some point like, oh, it's in 2-dimensional math. There's no dimensions in the math, and clearly the experiment happens in 2 dimensions in the sense they deliberately make the slit too tall for some third dimension diffraction to even take place, which would be, I think, more interesting would be to analyze some of these different shaped apertures, triangle apertures versus square apertures, and might be good cause to as a way of dismissing some of this theory, because clearly at the corners in like a square aperture you do get pattern that doesn't fit the math for either this slit or this slit. No matter which way you think you're slitting, this way or this way, the corners aren't going to be accounted for. So clearly there's something else going on, and I guess that's why they do keep it simple and always make them slits rather than squares, or worse, circles. So they avoid all the geometry that might complicate their propaganda. Distract them from their propaganda. Alright, anything else? Oh, I didn't have the mouse in the right place when I was explaining that. Well, my bad. Sorry about that. I don't think I did anyway. Well, it might be okay. Looks like there's a mouse moving there. Yeah, so it's picking it up regardless. Yeah, pretty sure. Alright, so anyway, Yeah, it's enough. I think. No, I'm tired. I already made the video. I'm gonna make it a second time. So anyway, sorry for the technical difficulties and such.